Greetings, one and all, and welcome to this lesson on vectors. Now, in a previous video, we considered what EP was, what SR was, what ER was. So if you haven't watched the videos wherein we considered how to find these, please consider watching those. Now we are on the final one, which says to state two geometrical properties of PQ and SR. So they want us to state two geometrical properties of PQ and SR. Where's PQ and where's SR? Notice that we have PQ here. So PQ is here and SR is here. SR is here. So we start from S, we end at R, we start from P, and we end at Q. So what are some geometrical properties that we can notice from this diagram, right? And from about PQ and SR. And not only from this diagram, but from the information that we are given. Let's look at it. Notice that which one is longer? Which one would you say is longer? Is PQ longer than SR, or is SR longer than PQ? What do you think? Is PQ bigger than SR, or SR bigger than PQ? Well, clearly we can see that PQ is smaller than SR, and SR is bigger than PQ. So SR is bigger than PQ. And the question is, how much bigger or how much longer is SR than PQ? Well, let's see. We know that SR is equal to, sorry, let's start with PQ. Instead of starting with SR, let's start with PQ. So we know that PQ, this vector PQ, so we know that the vector PQ is actually, the vector PQ is actually equal to, A bar. And the vector SR, is actually equal to, 2A. Now, how do we get that 2A? We got that in the previous video, and in a previous video, I think that was the first one, the first part. So it's three parts. We have part one, part two, part three. In part one, we dealt and we explained thoroughly how, or I should say in a more in-depth way, how we got to A. So if you haven't seen that, please consider that. So we know from part one, from video one of this three-part series, we know that 2A, SR is 2A. So SR is 2A. So look at that, right? PQ is A and SR is 2A. And so what that is telling us is that, listen, SR is actually 2 times as long as A. Let me say it again. What this is saying is that since PQ is A and SR is 2A, this is saying that, listen, SR is actually 2 times longer than PQ. So SR, we know, is equal to, going to be equal to 2 times A. But what is A, right? 2 times A. But what is A? Isn't A PQ? So SR is 2 times PQ. Okay? 2 times PQ. So that means that SR is twice as long as PQ. Okay, so this vector, and we can kind of see that in the diagram, although it's not, like they say, it's not drawn to scale, but you can see that SR is definitely longer than PQ. How much longer? It is twice as longer as PQ. Okay, so SR is equal to 2 times PQ. And that means that SR is twice as long as PQ. What else can we see from this diagram about SR and PQ? Well, PQ is heading to the right, right? PQ is heading to the right. So let's demonstrate that. PQ is, we start from P and we go to Q. So it's heading to the right. And SR, start at S, end at R, so we're heading to the right as well. Okay, we're heading to the right as well. So we can also say that these two vectors, right, are they're heading in the same direction. Okay, these two vectors are heading in the same direction. But now we got to be careful because all they ask us for is for the geometrical properties of PQ and SR. They're not talking about the vectors PQ and SR, but they're talking about the line segments PQ and SR. So we can't talk about the direction of these line segments, but we can talk about the direction of the vectors. Okay? So if we're just looking at the line segment PQ and the line segment SR, what we can say for sure is we can say that PQ, well, we can say that SR is longer than PQ, but we can't say anything about the direction of these line segments. But we can say that the vector PQ, right, and the vector SR, we can definitely say that these two vectors are parallel. Okay, and let me write this. We can not no sorry not parallel, not because we haven't introduced that as yet. I'm we can say that the vector PQ and the vector SR are heading in the same direction. Okay, so let's get this straight. What am I saying? PQ just refers to the line PQ. Notice there's no bar on top of this. SR is just referring to the line SR. And so we cannot talk about the direction of SR because that's just a line segment. But we can talk about the direction of the vector SR, right? How about PQ? The same thing. We can't talk about the direction of PQ, but we can talk about the direction of the vector PQ. And so the vector PQ, right, with the arrow, the vector PQ is going in the same direction as the vector SR. They're going in the same direction. So about the line segments PQ and SR, number one, we know that the line segment SR is bigger or longer, twice as long in fact, than the line segment PQ. What else do we know? That we also know that we have this here. So we have SR equals 2P, SR, I shouldn't say also, but we have here that SR is equal to 2PQ. What else? What other information does this tell us, right? What other information does this tell us? If we have one vector, right? If we have one vector written in terms of another vector, right, times a number, what do we say? What can we say about the vectors SR and PQ? Let me say it again. If we have one vector written in terms of another vector times a number, what can we say about these two vectors? Well, if we have one vector written in terms of another vector times a number, then we say that the vectors SR and PQ are parallel. Okay, that's another thing that we can get from this statement, right? So they're parallel. They're parallel. So the vectors SR and PQ are parallel. Okay, so let us, so these two lines, so the line segments PQ and SR is parallel. Okay, so PQ is parallel to SR. So that's two things we can say for sure about the 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 line segment PQ and the line segment SR. Number one, SR is twice as long as PQ. And number two, the lines PQ and SR are parallel to each other. Okay, so let's consider that. right? Let's consider that. Let's go here and recall in video 1, we saw that EP is equal to negative a half BA. We saw that. We also saw that SR. So this is the details of how we got 2A. And we also saw that ER was a half 3AB. Sorry, a half B plus 3 over 2B. Sorry, a half B plus 3 over 2A. Now we're considering the last question, which says, hey, since we have that, we consider the last question, which tells us to state two geometrical properties of PQ and SR. And so notice what this is saying. This is saying, note that SR, the vector SR equals to 2A, which is 2P, which is 2PQ. And since the vector SR equals to 2PQ, this means that the vectors SR and PQ have the following geometrical properties. Number one, the vectors are parallel, right? Number two, the vectors are scalar multiples of each other. If they are parallel, then they're scalar multiples of each other. That's what it means to be parallel, for these two vectors to be parallel. The vectors SR and PQ have the same direction, and vector SR is 2 times longer than PQ. So all this information is talking about the vectors SR and it's talking about the vector SR and the vector PQ. But we must be careful because the question did not ask us about the vectors PQ and SR. They asked us about the line segments PQ and SR. And so the only thing that we can say about this, or two things that we can say about this, is we can say that instead of writing the vector SR, we can say, because we're not talking about the vectors for this question, we're just talking about the line segments. So SR, we're just going to say that SR and PQ, SR and PQ. So that's SR and PQ. So we're talking about the line segments now. PQ are parallel. So that's one of the things we can say. Not the vectors, because we're not talking about the vectors, we're just talking about the line segments. So SR and PQ are parallel. And we can say also that we cannot talk about direction of line segments, but we can say that SR, the line segment SR, let's move that arrow. If we have the arrow, that means we're talking about a vector, but we don't want to talk about the vector. Let's talk about the line segment SR, because that's what the question asks us. So it's SR is 2 times longer than the vector than PQ. Okay, so we can write two geometrical properties of SR and PQ are the following. So this is the answer, what I have in red. What I have in red, what I'm going to put in red, not what I have in red. So what I have in red now, this is the answer for the question. So two geometrical properties of SR and PQ are the following. Number one, SR and PQ are parallel, and SR is 2 times longer than PQ. So they asked for the two geometrical properties of SR and PQ, and here are two. Number one, SR is parallel to PQ, and SR is 2 times longer than PQ. That brings us to the end of this video and the end of this question. And so in the video 1, 2, and 3, we answered this entire question in 3 videos. So thank you for your time and attention, and I'll see you in another video.